confidence interval for mu when sigma is unknown. So here assumption is population standard deviation is unknown, population is normally distributed, and if population is not normal, we need to use large sample. So since population standard deviation is unknown, we need to use S, which is the sample standard deviation. And since we are using S, which is the sample standard deviation, we cannot use the normal distribution. We need to use the student's t distribution. And now the formula for confidence interval will be the point estimate, which is the x bar, plus minus critical value. So this critical value comes from the t distribution, not from the normal distribution. And here the standard error will be using s over square root of n instead of the previous sigma over square root of n. In order to find the critical value from the student's t distribution, we need to know another concept, which is the degrees of freedom, because the value for t alpha over 2 depends on df, degrees of freedom. So degrees of freedom means that the number of observations that are free to vary after sample mean has been calculated. So the degrees of freedom, the formula is going to be n minus 1. So example n equals to 3, so degrees of freedom will be 3 minus 1, which is 2, and then suppose alpha is 0.10, so the upper tail area, so half of it, alpha over 2, is going to be 0.05. So how do we find the critical value from this? So we need to look into the t table. So we are referring to the upper tail area, which is going to be alpha over 2. So since alpha is 0.10, so we are referring to 0.05, and then the degrees of freedom is n minus 1, so 3 minus 1, so we are referring to 2. So here the value for the critical value from the t table is 2.92. Example, a random sample of n equals to 25, and we have the x bar equals to 50, and the sample standard deviation is 8, and we need to construct 95% confidence interval for mu. So the degrees of freedom is n minus 1, which is 25 minus 1, 24, and the critical value, which is the t distribution, we need to use the t because we are given sample standard deviation, so this is whereby sigma is unknown. So t alpha over 2, upper tail area is going to be 0.05 divided by 2, so we get 0.025, and referring from the table we get 2.064. So replace everything in the confidence interval formula, so we're going to get 50, which is the point estimate, plus minus from the table, which is 2.064, and the standard error, which is the sample standard deviation divided by the square root of n. So here meaning that we are confident, we are 95% confident that the true population parameter mu will lie between 46 and 53. Another example, we are given data for rental car costs for 12 cities. So this is 47 until 45, and we need to construct 95% confidence interval. So we need to find the information for the point estimate, which is the x bar. So sample statistic x bar is going to be square root of, summation of x divided by n. So summing up all this, 47 plus 41 plus 49 until 45 divided by 12, so you have 540 divided by 12, so you get 45. So this is the point estimate for mu. Since sigma is not given, so we need to calculate the sample standard deviation. So this is the formula for sample standard deviation. So you need to replace the n and the x squared, summation of x squared, and then the summation of x squared, and then divided by n, and everything is square root. So we get 6.179. So this is the point estimate of the sigma. So replace in the confidence interval formula. So this is 45, sample statistic plus minus, this is from the critical value, 1.796 times the standard error, which is s divided by square root of n, which is 1.784. So you have 45 plus minus 3.204. So you have 45, 41.8 and 48.2. So this means that we are 95% confident that the true population parameter which is the population mean car rental rate, is from 41.8 to 48.2. So alpha 10%. So upper tail area, which is 10% divided by 2, which is going to be 5%. So we are referring to T 0.05, and we have here the sample size is 12. So 12 minus 1 for degrees of freedom is going to be 11. So we have the critical value from the T table, which is 1.796. So the way to write this, you can write it as T and then subscript 0.05, which is alpha over 2, comma n minus 1, which is the degrees of freedom. So T 0.05, 11 is going to be 1.796.